All right, so I'll just give it a minute. Yes, I know it's full. I filled it up. Okay. All right, so let's talk a bit of a few administrative things. So first off, generally week by week, you want to go through and module one, click module one. We did that last week. So module two, you want to click this. And I didn't realize that there's a bit of confusing things here that I haven't removed. I'm going to try to get through it this week. But in general, a lot of the things here are good. So you want to try to, if you haven't watched these videos yet or read through chapter 2 of the textbook yet, you want to do either. This will cover basically the same material as the textbook. So it just depends as whether you prefer to read the textbook and run all the examples yourself, or you just prefer to watch the videos and then quickly click through the examples. Either is good. I give you that option. Okay. I will, and again, I've got to fix these links, but they would normally directly link to your textbook. So, although actually they should link to this page now. Yeah, I fixed that. So clicking that link will bring you to the page with all the due dates. So, and then there's a link to lab 2. Now there is mention of a quiz, but I'm not doing quizzes anymore in this. So I might keep the questions around as self-check so that you can see how you're doing. Right? So no credit, but like you can just see where you how you do on them. So I might do that because if I made a resource, I might as well use it, you know. But ignore these. Besides, you're late for it anyway. It should have been done in January. So yeah, so I've got to fix some of the dates. I'm sorry about that. But that's again, it's just been busy. In general, if you're just keeping up, if you keep up with this page and the lab assignments, it's fine. You're doing great. I will try to do our first exam week 4, week 5. Again, you will have at least 1 week's lead time. And again, the first exam we do, it will be a bit more weighted towards the group portion. So, but I will give you at least a week's lead time for that. It really depends on where I feel like I could ask interesting and not totally boring questions. All right. So next, what are we going to do today? All right. So, what we're going to do today is that we're going to go to Runestone. Okay. We're going to Runestone and we are going to scroll all the way down to project 2. We're going to do project 2 in class today. All right. Although I did say it will be Q&A, review session, and a short exercise. So first off, so I assume everybody's got in idle set up on their computer, right? So one of the issues that some students have been having is that they'll basically, let's go ahead and save as, let's see, I'm not gonna save. Let me go ahead and make a new file. Print. Hello. Save it. And now I'm going to go ahead and save it on my desktop. I'm going to save it as hello. PY. And they'll double click it and nothing happens. Or maybe they'll get a flicker on their screen. This is a common issue because and it just has to do with a peculiarity of how our programs are set up. But in general, let's see. But in general, the reason that's set up is because if you go to if you're on Windows, I don't know how to do this on the Mac, but the same idea applies. It'll be hard to see, but basically, if you do properties, it'll tell you how it's going to open the program. And if it's going to, and by default, if you install Python, the double click action is run the program. So I'll open up a window, it'll run the program, program's done running. We're done. Great. Awesome. And when it's done, it closes the window. And your programs run really fast. So it closes the window pretty much instantly. So if you double click and nothing happens, that's kind of why. So one way to change that is to click change and select how to open it. For instance, it by default will open with Python. And that's going to do exactly what I just told you it's going to do. Everybody saw that window open up. That's the default action. So what you want to do is change it to open with idle or whatever editor of your choice. Alternatively, because finding idle might be a pain, you can always right click on it and there should be an open with idle option somewhere, or edit in idle if you've added that to your context library, to your context. Otherwise, if you're having trouble open it, instead of trying to open your file from there, finally, and that neither solutions work, just simply open up idle and use the open dialog, Control O, Command O, or just select File, Open, and navigate to the file you want to open. Or you can just simply select recent files and it will open those up for you. So there's a bunch of different ways to do that, but that is why double clicking does not work. So does anybody else have like any questions that have like been nagging at them for the past weekend or so? Yes. Aha. Okay, so give me a second. I need to mute the projector and pause my sharing for a second because I'm going to a thing that might have, grades for a second. So I'm going to go to the instructors page over here, click on the grading tab. Let me actually stop muting it. And you're not seeing anything in the screen sharing because, I don't want to accidentally show people's grades, even though they're completely ungraded. I'm not supposed to, there's supposed to be things I'm supposed to do and not supposed to do. So I select assignment 1 readings. And then what I have to do is I hit this button, which I uncheck this to say, hey, I don't care about deadlines. And I hit it. And now since I've scrolled up, it will start doing this for all the students for these chapter 1 exercises. Yep, but now I start getting into a different issue, okay? Which is if we go over to assignments, okay, and I'm going to now resume my share. If I go into assignments and I go to the chapter 2 exercises versus the chapter 1 exercises, the chapter 2 exercises, scroll down, we'll have a score me. But now that I'm running the chapter 1 exercises, this score me over here will disappear. And then people will start freaking out because they think that they can't get a grade on it anymore. That's understandable. But that's also because there's just warning text that's very hard to read underneath it because, you ignore this. This is the bottom of it. The buttons are at the bottom. You don't read anything below the buttons. Scores of the problems you self-grade are unofficial. So if you hit that score me, it's unofficial. Some problems will need to be graded manually and your instructor may have requirements that cannot be auto-graded. So basically it's saying, so once I run this, and it runs for all students. Let's see. And it may not be running anymore because I closed that tab. But the idea here is once I run it, that score me button will disappear. Don't freak out if it disappears. That just means I've run the grader. And when I run it again, your score will be updated. Now, the grader stopped because I probably stopped because I closed that tab. Almost certainly. Yes, almost certainly. Yeah, so let me go ahead and assignment. Chapter 1 exercises, I will release the grades for everybody. So, and then what I have to do is I will uncheck this. So anybody who's done anything. So now it's just currently running through everybody and marking those. And so you should see a change. If there's issues, don't worry, just fix what was wrong and I will regrade it again. If there's, however, something existentially wrong with it, then let me know. Okay. But basically what I'm saying is don't panic about anything with the textbook. You should never panic about anything in the textbook. express mild concern, definitely. But panic with the textbook or the assignments, never. Okay. So, any other questions? Because that was a good question. Okay. And I can actually just check my assignments right now and see if I've been affected by this. Assignments is still going, it's probably still going on. So, okay. With that, let me go ahead and go to assignments, the instructor's page again, and I will now add the assignment for in-class exercise. They're currently also making a new version of the textbook with how to think like a computer scientist in a language called pretext. It looks nice and fancy, but since it's a different text, and I like this text because it has like a ton of projects, I'm currently using this one. The projects mean a lot to me here. Week 2, part 1, visible to students. Yeah, today at the end of today, not at like when you just woke up today. Sounds good. Allow late submissions, visible to students, save. Okay, that should now appear for you under the assignments. But again, to get to the full story, you'll want to click on because it's just going to show the problems. You'll want to go to our textbook and navigate all the way down to driving the turtle. Now, I love the turtle programming paradigm. It's based on the turtle graphics system. And what I was going to do was open up Wikipedia, and it's so convenient that it has a link straight for it. So turtle graphics. Okay. No, I don't want to vote for Wikipedia stuff. I don't need to. All right. So turtle graphics are vector graphics that don't need to worry about that, using a relative cursor, the turtle upon the Cartesian plane, X and Y. It is a key feature of the Logo programming language. And the idea between the Logo programming language, it was developed in in the late 60s as an educational programming language. And well, it didn't just really survive too much, like nobody really uses that right now. The concept of turtles really carried on. It's one of the, I personally love turtles as a programming language, as like a programming paradigm, because you get to see not just with text, but actually like visual drawing. Lab 3 will basically be, so not this week's lab. This week's lab is lab 2, but lab 3, which is next week, that will cover how to start dealing with that assignment will be going over basic stuff with turtles. I also will have to figure. I'll also be then working out with I'll have to alter due dates and stuff to account for the fact that Monday isn't going to have a lab, but that just means that lab 3 Monday will be on week 4. It's weird. I don't worry about it. That's my job to worry about it. Anyway, turtle graphics. The entire point of turtle graphics is that you've got this turtle, okay, and you draw stuff with it. Well, how exactly? Well, the paradigm for the turtle programming language for this is that we've got a turtle and we're looking down at this turtle with a bird's eye view. Yes. That's fine. Nope. These are all soft due dates. So again, yep. So that is worth mentioning again. All these due dates are that are listed in the textbook are soft due dates. This is when I expect you to have them done, but I will continually grade all these assignments throughout the semester without any late penalty. And that is because it is very easy to just simply miss a week of kind of doing stuff. I get it, you're busy. And these stuff is, again, and what I want you to do, be prepared for class, but is not where the majority of learning takes place. Okay, so the turtle paradigm is that we are looking at a giant sheet of paper, bird's eye view, and we're looking down of this turtle. And this turtle has a little pen attached to either his tail or his mouth, your choice. Okay. And what he's doing is that he's taking this pen and he's just dragging it along with him on the paper as he moves. So let me go ahead, and what I'm going to do is I'm going to comment out a bunch of the first lines. So for those of you who haven't seen this yet, what is a comma? A comment in a programming language is basically a symbol that says, hey, computer, everything behind this comment, everything behind this symbol is for human eyes only. You don't get to see it. More importantly, it's gibberish. You wouldn't even know what to do with it. And the computer's like, okay, whatever. So it's a very cool, so it's useful for two purposes. First is the primary purpose of what it's named for, commenting the code to tell you what it does. The second purpose of a comment is that you can use it to very quickly turn off a line of code and then remove the comment symbol to turn it back on. So here I'm just turning off some lines of code so that I can run it. Okay, and then walk you through it. So unfortunately, we need about 2 lines of magic in order to use a turtle. Okay, so we need 2 lines of magic. It isn't too much, but I can explain most of that magic. Okay, so here I will go and I will unzoom and I'll run it and then I'll zoom back in. Okay, so here you can see it and you can see it in action. I know it's hard to see from all the way up there, but I swear the turtle is moving. Okay, so the first magic line is import turtle. Not every program needs to use the turtle graphics. And if we were to include everything that needed to be used in every Python program, the resulting program would be very big, unnecessarily big. So we don't. We just simply tell, so aside from some basic commands that almost every program needs, like print or opening files or doing addition or some basic math operations, we don't really keep, you know, we need to import everything else. But there's very few things you'll have to worry about with that in this class. So import turtle basically says, hey, let's load up everything we need to use a turtle. That's what import turtle does. Not too scary. The second line, so this blank line, unnecessary, but it's just kind of traditional that you separate your import statements from the rest of your code. So if you were to do this, who cares? Not me. But it's just kind of traditional that basically you have all the imports that you might need up in their own kind of section. So next, the magic line is turtle, my turtle is equal to turtle.turtle. So this first turtle, the lowercase one, refers to this package that I just imported. We will learn more about this later, but I'm doing my best to explain it right now as we're going. So this simply says, hey, I'm talking about the turtle package. The dot means look inside of it. And then this gets into a bit of object-oriented programming, which is in the next semester. But this simply says create a new turtle object. In other words, this is the magic words that say make me a turtle. And I'd like to store this turtle in a variable called my turtle. That's what the equal sign does, right? My turtle. It's the equal sign stores thing. You might think, oh, it's equality. It says equal to. Try to, in this class, especially to remind yourself every time you see the equal sign, it is the assignment operation, right? Videos go over why that's important. And when I go over mathematical operations, I'll talk about that a bit more. But it's very important that you mentally say, my turtle is equal, aha, that's the assignment statement. I should think of it like this, like a nice arrow pointing this, basically setting this my turtle equal to whatever came out of this value. So those are the only 2 lines that are magic. We can kind of figure out what the other ones are doing. My turtle.color makes the turtle green. If I were to comment out that line, we can, and then run the code again, because it won't automatically update. It's going to run import turtle, my turtle, then say turtle forward. It's going to make it black, which is the default color. Makes sense that that black is the default color. It's like the default color for pens and stuff. Okay, so we could also turn it into, you know, any other kind of, primary color or primary adjacent color that we want. There's a list of turtles in the turtle documentation. Oh, sorry, why does it Ryan? I think I'm talking while I'm trying to do this, and that just doesn't work. Red. Okay, there we go. Whereas Ryan, right, it's not going to result in anything. Oh, results in black because it doesn't know what to do with that color. Okay. Red. Okay, so we've got a color, very straightforward as to what that does. It changes the color of the turtle, and therefore the pen that he's holding. We can change those independently, but we don't really need to worry about that right now. And then my turtle.forward. So again, the way we command the turtle to draw stuff, because that's what we're doing, we're drawing stuff, is by using the forward command and commands to turn it left and right and the commands to move it backwards. So that's, and because all the motion is relative to the turtle, it makes it kind of easy to understand and kind of easy to direct. So if I tell him to move forward 50, he's going to move forward 50 pixels. Again, pixels are those little squares, just kind of relative to his thing. If I tell him to move forward 500, which is 10 times as much, he goes off the edge of the screen. And if I could expand that screen, that's fine. If I did this in idle, I would, I'd be able to expand the screen and see where he went, but whatever. Again, we're on a Cartesian plane. Again, that means that it's an infinite XY coordinate plane with the starting location of the turtle being the center at 0, 0. This is relevant later on, but not really right now. In other words, he lives on that plane that you've been using since middle school, and so I've always wondered what the local fauna was for that. All right, so there's other commands in here though that make it do stuff, and we'll go through them. Okay, save and run this. And hey, I can go all the way back to the initial setting and run it, right? That's pretty cool. I love this. All right, so what did this initial color do? What did the initial setting do? It said, hey, we've got turtle, let's make a turtle. Hey, oh, we've got comments telling you what it's going to do. My turtle color is green. Set the color of the turtle green. Move the turtle forward 50 pixels. Now, my turtle up, you might think, okay, move him up, move him north, but actually it means something specific here. It's telling him, okay, the turtle's pen is attached to his tail, have him lift his tail. Lift his tail up. And if the pen's attached to his tail, it's no longer dragging on the giant piece of paper, which means he isn't going to draw, right? So we see this with the my turtle forward 50, the my turtle up, and then the forward 50, where he went 50 pieces of movement this way. Then we told him to move to lift his tail, and then he moved another 50 squares this way. Okay, we'll get to this other portion of what he did in just a bit. Okay, so the next step is my turtle right. So we have forward, and we also have right and left. Right and left doesn't move him right and left, it turns him right and left. Specifically, right means have the turtle turn right 50 degrees. Sorry, 90 degrees. Have the turtle turn right 90 degrees. So if I comment this out, we see that the turtle, he moved forward, and then he turned this way to point down. Now, you might be saying, well, Professor Rosen, that's not a turtle, that's an arrow. The default shape is an arrow. We can actually set it to be whatever we want. We'll be setting, as we get later into the semester, we will be setting it to the hurricane symbol when we build a hurricane tracker. And that's a lot of fun. So but the default shape is an arrow. So we simply move him, so he moved forward, then he lifted his tail, moved forward, and turned to the right. Then he did my turtle down, lifts the tail, and then the corresponding command to moving forward is to move backwards. Right? And he moved backwards, and so he just simply backed up. And also I know forward and backwards can be a bit much to write. So you're also allowed to do this. I think for forward, you can do FD to be shorthand for forward. I'm not sure if it works for backwards. I forget, or if it has a different abbreviation. Nope, not BD. Let's see if it back works. Because there's always these nifty little shortcuts they put in. Yeah, back. FD to go forward and back to go backwards. Those are just kind of shortcuts or, abbreviations that Python will understand. I almost said Java because, of course, I teach Java before this. So anyway, we can use a lot of these instructions to use quite a bit to result in like some very intricate patterns Python is very, 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 very good at making turtles are very good at making abstract geometric images. Those kind of spirographs stuff can be really simulated very well with these. And it's even possible to write a retro style video game using turtles. And it's a great learning exercise, but not necessarily the greatest platform for a game, but it's doable. So what I'd like you to do today, and before we get back and start looking at some other code, and I'm going to pause the lecture while we do this, is that I'd like you to try making your own drawing with turtles. Have fun and experiment with this. Now, for some of you, you might be able to do everything you want to do with just this stuff here. But you might be wondering, well, what else is there? So that's where we are going to look up the turtle documentation. It's easy enough to find it. Just simply look on Google Python turtle, and that should get you to docs.python/library/turtle. And that has a list of all the things you can do with turtles, as well as like example of some code that they can do. And they do it in a couple different ways, but here you can see, here's the list of like forward, backwards, left, right. Here's another one, go to. You give it a position, an X and a Y, right? Remember, I said it's a coordinate plane. So you can tell it exactly what pixel you want to go to. And it will just simply go there in as straight of a line as it can, drawing as it goes. You can change the X and Y. You can set a heading if you prefer to do it that way. You can use circle to draw circles. Oh, this one's a fun one. Stamp, which we'll learn later, which essentially, instead of using the pad, the turtle makes a belly flop and makes a stamp of himself. Turtle.undo. There's all sorts of things you can do with this. And it's a lot of fun to try to see what you can do. So go ahead and get started with trying to do whatever you want. This is a very, very fun way. And again, if you get stuck here, right? If you get stuck, you can always just simply go back to the beginning by after running it, dragging this history bar all the way back to the beginning. Okay. So go ahead and get started with this. I'm going to pause for a second and mute while I look for some examples, and I'm going to go ahead and let you have some fun with this. And again, feel free to collaborate with the people next to you. Strike up a conversation, make some friends. Like, I mean, we spent like a bunch of years in isolation. We should all be like feeling really sociable right now. Okay. Okay. So I'm going to pause the recording. Resume recording. Do people want more time to work on their things or to play around or? Okay. For those of you who are feeling who've read ahead or have experience, the next kind of step to implement with turtles is just if you know how to use for loops, that's kind of where we're going with this. Oh, and one last thing that I should mention. So if you are using idle or the web browser, this does not apply. You can ignore what I'm saying. However, if you are using VS Code or some other editor, okay? If you're using VS Code or some other editor to try to do your work, there is one line that you need, which is you do all your code, you put it there, and then again, this only applies if you're working in VS Code or whatever. You can put this in idle, but it's not, you don't need it. Same with over here, you don't need it. But that line is turtle.done. And what that's going to do is that it's going to tell the program to kind of just wait for you to close the window before automatically closing it, which is again, the issue that we were kind of having earlier in the class. So the web browser deals with that just by not closing the window at any point, and except when you run stuff. And idle deals with that with the fact that it's always got a REPL running, so that you don't need to the read, evaluate, print loop. So it doesn't close that either. So, but for if you're using VS Code or Spider or some other kind of thing, you want to use turtle.dom. Andrew's Guns and Ammo, if we can't kill it, it's immortal. Yeah. Unfortunately, they're all robocallers these days. So I don't get any satisfaction out of these things other than actually connecting with people and saying that their mothers are terribly disappointed in them. All right. So. All right, I'll give it about 3 more minutes and then I'm going to move on to doing a bit more talking about this stuff. The instructions are very much what you see, what you get. Yes. Yeah, that warrants a that does warrant me telling people. All right, so I'm still recording and still sharing. So okay, so the question was, how do I make my text bigger? Which is a very important question because I live and because I live by having my text be very large. Because the issue with these large screens and small point font is that you have to get really into them to see them. You can see a lot of text, but it's not useful. Also, I like do this, and like I have a class that needs to see this from afar, which means I need to blow up the text to be very large. So we can find that by going into on the top bar. There's a bunch of things over here, and you can just click on Configure Idle. The first tab in there is your fonts and font selections. I use Cascadia Code as my choice, but yes. All right, so yes, go over here. Thank you so much. Go over here to your options on the top. So file, edit, shell, debug, options, configure idle. And then you'll be able to select a font. I highly, highly, highly recommend choosing what's called a monospaced font. Unfortunately, this doesn't really tell you which are monospaced font, but what is a monospaced font? It is a font where every character in the font has exactly the same width. So your L's are just as wide as your G's. And we can see that basically that it's kind of that over here, we've kind of got a grid. If I were to look at, let's see, Cambria, it's a grid that kind of starts getting unaligned right around here when we get into the squiggly characters and symbols and stuff. So Cascadia Code, when in doubt, if you need something, Courier New is pretty much available on all operating systems. If you are running Mac OS, you may want to just look up the fonts that Apple paid a lot of money to designers for, to figure out what they made to find the coding font that goes seamlessly with their UI interface. I'm personally, my fonts of choice, by the way, are Cascadia Code or Cascadia Mono. Both do Cascadia Code just uses ligatures, which are a thing, which is a whole nother discussion for another day. That one's designed by Microsoft. If you are in need of but if you're a open source guy who really likes using open source stuff wherever you want, then I highly recommend Fira Code. The Fira Code font, which you can find on GitHub and download from there. It was commissioned by Firefox for their now defunct Firefox operating system, but it still looks really sharp. It's really good. And the government of New Zealand uses it for some of their governmental stuff. Pretty good. But anyway, it looks very good. So, but again, using a monospace font is kind of essential. Now, how do you increase the size? Right? Should be. So while you're here, there's right below a size. You just simply click that and change it to the size that you desire. So here I changed it to 34 and made it quite large. Generally, if you're not sharing your screen with other people, generally 16 is nice and big. But again, as resolution, depending on the resolution and the scaling settings that you're using, which is a whole different discussion, you may need to blow up your font size. Okay. So while you were working, I was coming up with some examples. So first and foremost, we've got this, I've got this code that's very straightforward. In fact, it begins with doing for. So first I created a turtle. I stored my turtle in the variable name Bob. So I'll be calling my turtle Bob. This is because Bob's 3 letters and essentially one syllable, pretty much. So it's very easy for me to say, very easy for me to spell. Very easy for me to type. So Bob is my turtle, and then I tell Bob to go forward 100 steps. Then I tell him to turn right 90 degrees, make a sharp right turn. Then go forward, make another right turn. Then go forward, make another right turn. In fact, I tell him to do it 4 times, which means he draws a square and ends up back where he started. Right? Now, if you've done so, and the way I did this, by the way, was I was pretty lazy. I just simply wrote this line, took this, copy, paste, paste, enter, paste, enter, paste 4 times, paste it 3 times. But but one of the things we do in programming is that we like to be lazy. And if I was having to make a 100-sided shape, or a megagon, which is a 1,000,000-sided polygon, things you learn when you have a 5-year-old who's interested in shapes. So then copying pasting that a bunch of times gets really old really quickly. So if I want to run something, if I want to repeat something an arbitrary number of times, I use a tool that's called a for loop. Now we get into for loop in week 3 that we're my videos, but I like doing exposure to these things multiple times because that's more chances for it to stick the first time. Because there's multiple first times. So first, I'm going to give you this magic bit of code, okay, which is for blank underscore I put there. You can put whatever you want. Some people put I, but because we don't need to use, since it doesn't matter, I'm just putting a blank there, the underscore. For blank in range, open parentheses, for close parentheses. So notice that a bunch of the words light up in color. The for and the in lit up in purple. That means that those words, just like import over here, are keywords. It means that if you can never really write them over. They're protected. They're special words that have a special meaning. Okay. But anyway, for blank in range, they have special meaning in here. And then I put in for, and then a colon. That colon's important. Okay. And then what I do is that but this is basically the magic phrase, the incantation I want to make to say, repeat the following thing 4 times. And so what I do is I take these and to anything that I wanted to be repeated 4 times, I indent into this. So indentation is how Python knows what is inside something. I mean, it's indented inside it. It's visually easy to see. So this is equivalent to the code I just wrote. It says, do this stuff 4 times. 1, 2, 3, 4, right? 1, 2, 3, 4, made 4 lines. If I didn't indent it right, like I had it like this, right? It would move forward 100, it would do the turn, we would do the advance forward 100 times and then turn once. Yes. Yeah, you can yeah, so what I did, right, is I selected the lines I wanted to indent, and you can select multiple things at once by holding down shift and using your arrow keys, right? Now, for some of you, that may seem blazingly obvious, and to others of you, this may seem like, like, why hasn't anybody told you about this before? And this is because a lot of people who teach you don't know how to use computers. So anyway, and a lot of things, honestly, I found that was the case for me. So much of the stuff I found, so many of the interesting program kind of things I found accidentally. But anyway, you can just hit tab and do that and indent everything all at once. Every line you selected. Incidentally, you can also press shift tab. It does the reverse, right? You notice that the tab has 2 arrows. Well, to go the other way, you hit the shift. Anyway, that's what's inside. That tells you what's inside of it. Now, this number tells me how many times I'm going to repeat this. So if I change, so this was 4. If I change it to 3, these lines will only run 3 times. 1, 2, 3. Doesn't do it the 4th time, right? Makes sense. I said this is the magic phrase that repeats the code. Whatever number I put in here times. So if I put it the number, let's go with 20 in here. It's actually very useful because you see he is going and drawing. Now, interestingly enough, our turtle is a very neat painter and a neat drawer. Unlike humans, if he draws over the same things, he's just going to keep drawing on it and it doesn't get smudged or anything. So, and then it did 20 times and it stops. Of course, things do get a bit interesting when we don't turn the same amount of degrees each time. Maybe if we're a bit off. Let's go ahead and turn this down to 50. 50 forward so that the turns are smaller. And let's go ahead and make the turns, let's say 87 degrees. It's a very easy way to make geometric figures. Like I said, this thing is very good at making geometric figures. And all it's doing is saying, hey, do the following 20 times. Move forward 50, then turn right 87 degrees. You did that once, good, do it again. Go forward 50, turn right 87. It's literally repeating this thing 20 times. Now, in other programming languages, there's ways to do it. This is how you do repetition a certain number of times in Python. It's a very convenient way to do it. We can, oh, I've got a question in the chat. Why did you leave the underscore? Did it create a variable called underscore? It's essentially a way for me to create no variable because I didn't need a variable. Some people will say, hey, use a variable here, but honestly, that's going to add a bit too much at the moment, and I don't necessarily want to do that. But then again, some of the examples I pulled did do that. So, for instance, over here, this is one I really liked. So let me get rid of this extraneous turtle that doesn't. So painter turtle. What this does is that it first changes the color of the pen of the turtle to blue. And here they said for I in range. Again, it doesn't matter what you put there. You could put blank just as easily here because we're not using the I. We're not going to be using any of that. And here he says, move forward 50 degrees, painter, and then painter turn left to go counterclockwise. And then they change the color and then says do 100. So let's see how this one runs. So here it's doing turns of 123. Now a 120 degree turn is kind of the turns you need to make a triangle, which sounds a bit weird when you think triangles are internally like, aren't they like 180 degrees? So you need 60, 60, 60. Right, but on the outside for those turns that you need 120. We'll get into that in more detail in a bit. What's going on there? Oh, yes. Time limit error. Program exceeded time run limit. So this is one of the safety features that is built in to your web browser, which is that if your program runs for too long, it will just simply crash the program. It says add some print statements to figure why it's in it, because if you're running a web browser and you accidentally hit an infinite loop, it doesn't want the infinite loop to crash your web browser with all your nice tabs open, right? So over here, we can change the amount of time that we allow this to run. So we can say system, and so rather than, so I could say, hey, milliseconds. So let's see, if I want to give it a 1 minute time limit, then I would do 60,000, I would presume. Do I have to import SYS? Yes, I do, which is seeming to get a lot of steps. So we can actually do one other thing to make this a bit better. Okay. Which is, oh, and load history, by the way, to get all your code back. So rather than doing, so I could do it like this to give it more of a chance to run, but honestly, it's still going slow. So one thing we can do with Turtle Graphics is speed it up. Turtle.speed, yeah. I just couldn't remember if it's Bob. No, it's Turtle.speed. So. Yeah, no, I'm just trying to remember if it's package size. Okay. Anyway. Do I use Turtle or do I use Painter? Let's go ahead and try. So let's go ahead and try this again. Turtle. Let's try painter.speed. And then I give it a number of 1 to 10. Let's see. But there it goes. Hey, giving it a minute gave it enough time to complete. So there we go. So it was able to build two kind of colored things on top of each other. Okay. I think, yep, 1 to 10. But however, if I say set the speed to 10 over here, you can change the color at which it draws. So I created my turtle, said, hey, set your speed to 10, and it's going to go pretty darn fast. 1 is slowest, 10 is fastest, and then 0 is do it as fast as possible, even if you have to skip drawing some things and they just magically appear. So that's cool. My other favorite one is for geometric stuff is this, which is where we get this really interesting illusion of 3D-ness as it starts to draw. But what is it doing here? It's saying, hey, do this 180 times. Move forward 100, turn right 30 degrees, move forward 20 degrees that, move forward 20 that way, then turn left 60. So in other words, so 30 this way, then turn that way, and then lift up the pen, go back to the center point, and get ready to draw again, and then rotate, rotate 2 degrees. Here again, the speed was not fast enough, so I'm going to set the speed to 0, which you would think means go really slow, but it means literally do this as fast as I can. And so with 180 of these, it will be able to just draw it really quickly. And you get this really interesting kind of figure with like, it's got like this illusion in it right there, where basically it's rendering these kind of weird arrows that just come up from it, from the computer having to draw black pixels so close together. Now, here's a cool feature that of my textbook, of this textbook that I love. This button right over here, because I'm sure some of you are trying to furiously jot down that code, and I'm not giving you the chance because it's useless. I hit this button, and it says, you're about to share this code with all your students. Okay? And what you need to do, all you have to do to access it is reload the page, and it will be in your load history. Makes it very easy for me to share code with you. So let's go ahead and talk, let's skip ahead a couple weeks and talk about the final exam. Okay? One of the questions I've consistently asked on the finals exam for the past 2 semesters has been essentially, here is a bunch of obfuscated turtle code with a bunch of variables that don't make any sense. And really terrible comments, like comments that tell you like this variable controls how groovy the thing is, or you know, or these variable values, they're traditional. What kind of traditional? I don't know, it doesn't say. They're traditional though. So basically it draws something, and the question I ask you is generally, I've been asking for that question is, here's a bunch of code. I want you to mess about with it on your computer and kind of figure out what adjusting these variable, like, and I ask you, like, what does adjusting this variable does? Oh, it adjusts the size of the figure. You know, this variable controls the size of the figure. This variable controls, you know, the angles at which things are formed, you know, those kind of things. So that's a question I consistently ask on the final exam, and I see no reason not to ask it on the final exam again. Yes. You'll be able to figure it out with all the stuff you've learned in class. You not this class, but like in the next couple weeks. And I like it because it's code that you can kind of like tear into as you're working on it. And it might be a viable thing for the first exam to kind of do before on a more basic level, you know, without it being too insane. But I kind of like that. And so, because I like being able to give you code and you to try to figure out what it does. Also kind of it kind of shows you from my perspective what it looks like when you give me bad variable names and I'm trying to dig through it. But that is the gist of doing these. So now on another side of things, if you go back to your assignments and check your assignments page now, you should have been graded on exercise 1. There should be something over there. I got it not started because I literally haven't done anything. You know, I didn't go through it. I'm the professor. Why would I go through it? But you'll probably have a grade anywhere between like a 0 and 100. if you've got a 0, again, express mild concern. Don't do, it's not something to get too worked up about. Because, so what you need to do in order to get 100 is fix those problems, and it will fix it when I run the grader again. Now, what you will notice is for now the question for the chapter 1 exercises is that there is no longer a score me button. That happens whenever I run the grader. There's no longer a score me button. Is that something to worry about? No, it's just the peculiarity of the textbook and the way it works. So once you do this again, though, I'll rerun the grader, and that will work. And it will update your grade accordingly. In worst case scenario, you just show me you did it, and I can always change your grade manually near the end of the semester, but definitely let me know if it's not updating. Okay. So now backtracking again once more to this problem over here. When I was mentioning something about how 120, that's pretty close to a triangle, which is a bit odd because, again, triangles, you think them close to like 360 degrees. So let's go ahead and see that in action. Bob is equal to turtle dot turtle. Also, one more reason I use Bob is that Alice and Bob are metasyntactical names that are used in computer science examples because they're A and B respectively, and also very short and easy to spell. So Bob dot board 100. Sorry. Bob dot, and then I can do a left turn by saying either left or LT for left turn. And so let's see what happens if I do a 60-degree turn. Turn that way. So let me show you what happens if I copy this and paste it 3 times. Right? Triangles have 3 sides. So what I get is, again, I turn this way, and then I turn 60 degrees and go this way, and then turn 60 degrees, go this way. So the reason we're not getting a triangle here is that the inner degrees of an equilateral triangle are 60 degrees, right? The inner degrees. But we're not working from the inside. We're busy drawing the outside from a turtle that's on the outside. So he's going to be, you got to use the outside angles, which is, in this case, the outside angle is basically whatever you would need to add in order to make it up to 100 to 180. Sorry, so be 120. And mind you, if you're too tired to do that math, you can always say, oh, I needed to add up to it was 60. I needed to add up to 180, but I'm too tired to do that math. You can always do the math that way. So, you know, Python's useful like that. And there we go, an equilateral triangle. So, now as we move on throughout the semester, we'll figure out how to make these things more generic, how basically you can just take a user's input and they tell you how many sides they want, and this will just simply neatly give you how many, you know, a figure of that many sides. It's pretty convenient. But for right now, this is a pretty good stopping point for today. So be sure to, in order to get full credit for this assignment, to have run the first code block, the second code block, which is what you did, and then to complete the post projects things, which I do care about, whether you're in the comfort zone, whether you're actually engaged in learning, or you're panicking. How long did this take? And then does this seem interesting? And if it doesn't, well, that's okay. All right. So I am available to take demos very briefly or answer questions.
I was asking the previous questions.